Hello, hello, physics. This is the first of two videos going over homework problems that you guys requested. This one I'm going to be going over homework problem 7, and then in the next one I'll hit 14. So this is the cat burglar problem. This is very, very similar to the stoplight problem, except that we have only one inclined wire instead of two. So, first off, it tells us that we have a 660 Newton cat burglar. Now, I've had a couple people in the past get confused by the phrasing of this. When we say that we have a person, or we describe someone as 660 newtons, Newton is force. Okay, so we're just giving you their weight. That's all that is. It's his weight in the metric system, and just instead of the English system. In English, we'd say a 200-pound man walked in, and that would be the same basic information. So this is just reporting his weight. So a 660 Newton cat burglar is supported by cables in the figures below, assuming the angle theta of the inclined cable is 30. So this is 30 degrees. Forgot my marker. So this is 30. Okay, and we have a horizontal cable, an inclined cable, and a vertical cable, and a point at which all of them are connected. We want to determine the tension in each cable. Now I'm going to call these T1, T2, and T3. Now, based on what we've talked about in the past, everybody should immediately be able to determine that the only force acting on this entire system is this guy's weight. And that weight has to be being canceled by T3. So T3 has to be his weight, which is what we see here. The vertical cable has to be equal to his weight. And it is, so that's one down. Now we just need to do the horizontal cable and the vertical cable. And these are a little easier. So we have angle cable, vertical cable, horizontal cable. That's not horizontal line. Let's try that again. There we go. Now, if this is 30 degrees, then this also has to be 30 degrees. And so that will allow us to do our triangle. Now, yes, it is also possible, if you really wanted to instead, you could put the triangle on top. That's just never quite made sense to me when I tried to do that, so I'm not going to do that here. So this is T1, this is T3, and this is T2. So our triangle for T2 looks like this, where T2y is the vertical component and is opposite, and T2x is adjacent. So the horizontal leg would be T2 cosine of 30 is equal to T2x, and the vertical would be T2 sine 30 to get T2y. Y is up, x is to the right, so both are going to be positive. Is that the first time I've had a bell show up in a video? It might be the first time I've had a bell show up in a video. Okay, I need to do my sum of forces now, so I'm going to clear this and put a white screen up. So I will be back in just a moment. All right, so, I'm going to put my marker. Hang on. All right, let's try that again. Okay, from here, we're going to write our sum of forces equations. Now, I'm not going to use the table again. I'm going to show you another way to do it. I'm going to do it the same way that I did in the friction video. Hey, there's another alarm. I'm going to show you, or I'm going to do it the same way here that I did in the friction video, where we're just going to determine them without actually writing out the table. Now, we only have one point to really consider. We're doing the equilibrium at this point here. So we have the sum of forces in X and the sum of forces in Y. Now, there are only 3 forces here to work with. Now, what we can do is we can say, erase this, and say that we have a vertical T2Y and a horizontal T2X. And that might be a more useful way to think about it for this. So in X, we have the positive T2X, which is this right here. So T2 cosine of 30 minus T1, which is horizontal, so it's just all of T1. And he is not moving in this, so this is equal to 0. Sum of forces in Y, we have the positive T2Y, which is this. So T2 sine of 30 minus T3, which is down, is also equal to 0. And just from here, you should be able to figure out what to do. So we have T2 sine of 30 equals T3, and T2 cosine of 30 equals T1. Well, we know T3. We know T3 is 660, so we can plug T3 in here to get T2. And then we know T2 at that point, so we can plug T2 in here to get T1. And that's it. It's really just plug and chug from this point. So that's it for this video. Let me know if this is not real clear, if you're hung up on exactly what to do, but that's pretty much it. Have a wonderful one, and I will see you in the video for problem 14.